Okay, 6.5, making connections, logarithmic scale in the physical science. So in science, we use logarithm a lot. One of the area that we use it is in chemistry. When you want to find the acidity or how basic or acid is a material or is a solution. So we measure the concentration of hydrogen ion. But since this hydrogen ion, let's say it is 10 power negative 4 mole per liter, it's going to be very small number, not conveniently we can work with. That's why we want to convert it into another scale. And conveniently, we know using the logarithm can help us do it. So we take a negative log of that number. Let's say negative log of the 10 power negative 4 is give us the pH of 4. So it's a good number, right? If you do measure different substance, so the pH will be a range from 0 to 14. 0 means your substance, your solution is very acidic. 14, the close number to 14 is very basic. And 7, if you have pH of 7, is neutral. So basically concentration of the your hydrogen ion at 14 is 10 power negative 14. Concentration of the hydrogen ion when the pH is 7 is 10 power negative 7. And concentration of the hydrogen when the pH is 1 is 10 power negative 1. So basically this side you have a bigger concentration of hydrogen than this side. This is going to be acidic. You know that more hydrogen ion means more acidic. Less hydrogen ion means more basic. Okay, what is the pH of the tomato juice that has a hydrogen ion concentration of 0.001? So basically concentration of the hydrogen ion is 0.001. So you can write it in form of 10 power negative 4. Then you use the formula, pH is negative log of that concentration. So you can bring the power in front. So negative 4 in front is going to be negative of negative 4 and log of 10. So you know the base of this log going to be 10, right? Because there's nothing is written here, is 10. So log 10 is 1. So basically the pH is 4. So we can, okay, blood, the hydrogen concentration of the blood is 410 power negative 7. Is acidic or basic? So we take a negative log of that concentration. We use your calculator. Is 6.4, okay? 6.4, so it's going to be less than 7, so it's going to be acidic. So the next one is the pH of the orange juice is 3. So what is the concentration? Now the pH is given to you. You're looking for concentration. pH, units of pH, you put 3. Now you need to turn the logarithm into exponent. So first bring this negative here. Then you know how to turn the logarithm into the exponent, right? So the base here is 10 to the power of negative 3 will give you the concentration of the H+. Concentration of the hydrogen is 10 power negative 3. Okay. Decibel scale. So beta 2 minus beta 1 is a difference between the sound level in decibel. Is equal to 10 log of intensity of second source divided by intensity of the first source. Let's just look at this example. Normal conversation has a sound level of 60 decibel. A whisper has a sound level of 30 decibel. We say that because this is decibel, it's going to be beta 2 and beta 1. Let's say your beta 2 is this, and here is your beta 1. How many times as intense is normal conversation compared to whisper? So 60 minus 3, 60 minus 30. So it's beta 2 and beta 1. I want to find the ratio of this intensity, right? How many times as intense is a normal recitation compared to whisper. Means I2 divided by I1, I need to find. So you just put everything that you have. Beta 2 is 60, beta 1 is 30, and you're solving for I2 over I1. So 60 minus 30 is 30. So you have to divide both sides by 3, right? By 10. Because you don't want to have 10 at this side beside the logarithm. So 30 divided by 10 is 3. So you have 3 log of I2 divided by I1. So the base of the log is 10. So 10 to the power of 3 is I2 divided by I1. Basically, I2 is 1,000 times bigger than I1. Any question, Theodore?
No.
Okay, let's continue. Let me erase that. So sound level of normal city traffic is 85 decibel. Let's just take this one to be B1. And sound level of the snowmobile is 32 times as intense. So a snowmobile is your second source, right? Basically I2 over I1, because it said that many times intense as the other one. Is 32 times intense. What is the sound level of the snowball? So basically, I want to find beta 2. This is the question. Now I know the formula. Beta 2, I want to find beta 1 is 85, 10 log. I2 over I1 is 32. So you just bring negative 85 to the other side. You use your calculation. Log of 32 multiplied by 10 plus 85, you get 100. So beta 2 is the sound level of the second source is 100. Any question?
No.
So we have another application is Richter. Richter is the level that you measure, is a scale that you measure the earthquake. You have might heard that in the news say that is 5 Richter, 4 Richter, 3 Richter, right? The earthquake, but then they want to do it in the news, they use a Richter. So M is the magnitude of the Richter is equal to log I2 divided by I0. Is I is intensity of the earthquake. I0 is a standard intensity of the earthquake because it's low level intensity. Okay, let's just do a question. How many times as intense is the earthquake of a magnitude 2.4 compared to a low level earthquake? Means I need to find I over I0. I want to see how many times this earthquake is intense compared to the I0. So if the magnitude is 2.4 here, so then you need to convert this one to the exponent. So 10 to the power of 2.4 is equal to I over I0. Any question?
No.
B, what is the magnitude of the earthquake that is 1,000 times as intense as a standard earthquake? So basically is I over I0 is the comparing of the intensity, right? I over I0 is 1,000. So you know the 1,000 is 10 power 3 and the base of the log is 10. So basically 10 to the power of 3 is 10 power 3. So the answer is 3. The magnitude is 3 Richter. Okay, so I'm gonna tell you what question you do here. So for question 1, you just do part D. Part D for question 2. And here do part B for part B. Okay. You just need to go down. Okay. And okay. So then you do question number 8 and question number 9. You got it?